Great. Good afternoon and welcome to MetalCon Live, everyone. I'm Judy Geller, Director of MetalCon here with Kaylin Burke, and we're so glad you could join us today. Today's session, Metal's Role in Sustainability, is presented in partnership with Metal Architecture and sponsored by F5. But before we start, I'd just like to share something exciting we are developing that's going to take place at MetalCon next October that is specifically for architects. It's called the Architects Experience at MetalCon, and it is an exclusive program comprised of education, architect-level speakers, an exciting off-site tour, and the opportunity to learn about and see firsthand the beauty and durability of metal while earning AIA continuing education credits. Stay tuned, we'll be sharing a lot more information about this new program in the coming weeks. Just one other quick reminder before we start. Our next MetalCon Live session is presented by Raina, obviously focusing on rain screens, and will take place 2 weeks from today on April 21st. If you need any technical help during today's webinar, reach out to MetalCon support in the chat box, and don't forget to complete the post-webinar survey so you can earn your AIA learning credits for today's session. And without further ado, I'm going to hand it over to you, Paul.
Thanks, Judy. Hey, welcome everyone. I'm Paul Deffenbaugh. I'm the editorial director at Metal Architecture magazine, and we've assembled a panel of industry experts on metal and sustainability today. I'm looking forward to a great and probably wide-ranging discussion. We're going to begin with 3 brief presentations by our panelists, then follow up with open discussion. Well, we've got some questions prepared, but please bring up your questions. This is supposed to be a very interactive presentation. My goal is to be a moderator and kind of fade into the woodwork here and let the real experts speak. I'll monitor questions and raise them with the panel. Our 2 architects on the panel are Rick Schneider, FAIA, principal of ISTUDIO Architects in Washington, D.C., and Hafsa Burt, AIA and studio head at hb+a Architects in San Francisco. They're going to talk about a couple of projects they've done to give us a groundwork for our discussion. And then Bob Zabcik, who's a professional engineer and is technical director for the Metal Construction Association, is going to provide a larger context for metal's role in sustainability. After those presentations, we'll jump into our discussion. Thanks again to S5 and its support of the industry education for making this possible. And Rick, we're going to begin with you.
That sounds great. Thanks, Paul. So before we start this video here, I'll give you all a little bit of backstory. The Marvin Gaye Recreation Center is a project we delivered in 2018. We're pretty excited about some of the national and international recognition the project has received for its cutting edge, sustainable design strategies. For example, we've, daylighting defines the architecture on this project, which you'll see in a moment. It's the first project in Washington, D.C. with integrated natural ventilation, and it's the first resilient hub in Washington, D.C. So the sustainability part has a lot to do with what you'll see in the slideshow here. But as far as metals go, the project is basically metals from soup to nuts. It's got a steel structure, steel components like stairs, rails. It's got decorative steel on the front, the reception desk at the front. And then as you go outside, the entire thing's been clad in steel panels. And then there's a perforated aluminum screen that actually helps to control daylighting, control solar gain, to provide a more energy efficient interior, as well as a comfortable interior for the occupants. That being said, I'll let this 5-minute video here speak to the rest.
The Washington, D.C. Department of Parks and Recreation approached our firm, ISTUDIO Architects, to design the new Marvin Gaye Recreation Center in Northeast Washington, D.C. As it turns out, Marvin Gaye grew up in this neighborhood and went on to become one of the most famous gospel and R&B singers of our time. We were tasked by the agency to design a facility that met the community's needs in terms of recreation, fitness, and education. So we designed the facility to meet the agency's mission of promoting health, wellness, and access to the outdoors. Marvin Gaye Recreation Center is the first public facility in the nation's capital with integrated natural ventilation. Daylighting and natural ventilation strategies define the architecture here. The perforated metal panels on the south elevation control heat gain, glare, and provide light, air, and views. Biophilic principles in design like this promote well-being and contribute to community resilience. The project itself sits in the 100-year floodplain, which is looking more and more these days like the 20-year floodplain. So we raised it off the ground and made it accessible with sloped walkways. We kept the footprint small and cantilevered the second floor out over the floodway to provide a place of refuge and respite for the seniors. Now, a treetop balcony overlooks the creek below. We like to say, this building breathes. When conditions are right, like temperature and humidity, the building air conditioning automatically goes into passive mode. These louvers on the first floor open up to let in cool, fresh air and expel the hot air through solar-powered exhaust fans on the roof of the second floor. The building takes in a breath of fresh air and then it lets it out again. Hot air rises, which, as it happens, is a very powerful force of nature. Temperature and humidity, this light goes on and it tells people in the room, open the windows, and it kicks into natural ventilation mode. So I'll go ahead and open those windows right now and you can hear it. Right now, mechanical systems. If I step over to the window, currently you can hear air conditioning in the room. If I open the windows, you can hear the sound of the natural ventilation system kicking. Hear that? That's the sound of natural ventilation. Rather than burning coal in a coal-fired power plant for electricity in western Pennsylvania, we're now using the power of nature to provide cool, fresh air for the building. We're taking advantage of the fact that hot air rises naturally, which is a very powerful natural force. Natural ventilation, as it turns out, is a great way to save money, cutting back on fossil fuels and thereby mitigating climate change. It also allows the building to be more energy independent, which is a great benefit during power outages. It's another way the facility was designed to be resilient. The Urban Sustainability Directors Network selected Marvin Gaye Recreation Center as the city's first Resilient Hub case study. We're often asked, how does sustainability and resilience inform the buildings and landscape that we designed? What we found out is that when we design for sustainability, it looks a lot like design for resilience. Our approach is to understand the cycles of nature and to emulate them in design. We avoid fighting powerful forces like the sun, wind, and the rain, and instead, we want to harness these powerful forces to create healthier buildings and improve our ecosystems. Done right, this helps to mitigate climate change and provide strategies for climate adaptation as well. In a nutshell, green buildings are more resilient buildings.
Hey, thanks, Rick. That's a great presentation about a great project. Hafsa, you also have some a project you wanted to share with us. Hafsa Burt, AIA, is the studio head at hb+a Architects in San Francisco, and she has some great ideas about how we can spread the word about metal architecture and sustainability. So, Hafsa.
Thanks, Paul. So just a little bit of a background on us. Since the inception of the firm, we have been big on efficiency, whether it's in processing, production, communication, and of course, construction. Experimentation is the essence of our business. We have specified metal products in our retail and commercial work. Please continue. And of course, our work at San Francisco Airport, where we used Aluka bond for cladding. Next, please. This is our work at San Francisco Airport with Aluka bond cladding. Next, please. Today, I'm presenting a project which is a prefabricated single-family home, 1750 square feet, located in California. Next, please. And it sits on a 9-acre site on an existing pad where most of the site was left completely untouched and the existing ecosystem of the site was left completely undisturbed. The single-family residence is zero energy, zero carbon. All energy needs are supported by on-site solar array. It is not connected to any utilities. Water is comes from an existing well, which is 300 feet deep and is pumped up by a DC Grand Foss solar operated again. It uses high R50 insulation in ceiling and walls, and all the windows are dual pane with low E. It's completely electrical ahead of the electrification mandates in California, and it has a 100-foot boundary for wildfire prevention and wildfire precaution. It also is stormwater drainage is accomplished by 150 feet long pipes, which are connected to downspouts and go all the way down to the hill. What else? It has won several awards and has been published. And the idea of this project came because the firm was working on a single-family traditional stick frame construction of a similar square footage in the Bay Area. And during planning and construction phases, I started noticing some inefficiencies which were completely out of our control. And so while that project was under construction, I had already designed, planned, gotten approvals, customized the prefabrication bit of it, and sent it for prefabrication, all while that project was still under construction. So the project has exceeded all its energy goals since it's zero energy and zero carbon, and right now serves as a retreat for industry peers. And that's about all my presentation. It also has panoramic views, complete access to daylight. All the interior materials were specified with occupants' health in mind, focused on IAQ with low or zero VOC. All the windows are operable, and the occupants have complete control of their environment to enjoy living in an undisturbed natural setting. Thank you.
Thanks, Hafsa. What a great project, and what a wonderful place to hang out. I'll show up next weekend if you don't mind. Bob?
Please do.
Bob, you have, give us a bit of context. Those are the two projects we have now that we're kind of setting the groundwork for what we're talking about. Give us some context about metal and sustainability, if you would, please.
Yeah, sure, Paul. So, we've been working for years at Metal Construction Association. Before I was technical director, I joined, I was with the member manufacturer. And we tried really hard to be open and participate in these transparent processes that are present for data gathering. And one of the things that we've done, and this is not unique to us, it's a lot of industries have gone the EPD or Environmental Product Declaration route. And that's got a couple of slides here. I just want to talk briefly about that. There are 3 that are available for download from the MCA website. There's one for insulated metal panels, one for MCM materials, like what Hafsa showed, and then also basic metal rule form cladding, and it is both roof and wall panels, aluminum and steel, covered in the scope of that document. As I mentioned, you can go get those documents on metalconstruction.org, or you can access them through UL Spot. So UL acts as our program operator. They are the ones that facilitate the process of gathering the data. But it's basically, you get a bunch of manufacturers into the room who want to participate, and we share as much as we can within our antitrust agreement. We share our processes and how we move product through a system, and we're really focused more on resource usage. What are we using in terms of water, electricity, input, materials, etc.? How far do we tend to ship our project or materials for our projects? And so all this happens in the presence of a facilitator. Then they, after these discussions, they send data surveys out, and all the manufacturers participate in that data survey, and it produces a document called an EPD. And EPDs have to be done in their certain scope. Go ahead and go back one. No, you're good, Kayla, right there. And so those EPDs and LCAs, the life cycle assessment has behind it, has to be done to a very specific scope. Ours is what they call a cradle to gate scope. Not cradle to grave, cradle to gate. So that basically covers all the input materials, getting them to the plant, fabricating the materials, and then shipping outbound product in terms of, this is the one for roll form cladding. Again, we have metal composite materials and insulated metal panels as well. And those scopes then dictate, what your output processes are, or your output materials are. They take that data and they model it. Next slide, please, Kayla. So the modeling goes into a series of tools. They use Tracy in this case. And basically for these materials and what's your declared functional unit, which in our case is a square foot of materials, roof or wall cladding materials, and they produce this data, which looks, very much like rough raw data, but in fact it's quite processed, and each one of these units is expressed, set on an ISO standard. But there's a unit for global warming potential, which is basically equivalent CO2, kilograms of CO2 emissions, ODP, ozone depletion, AP is acidification potential or acid rain, EP is eutrophication potential, so that is the nitrogen-based products being released into the water stream for causing algae blooms and things like that. SFP is smog formation potential, and then a newer one that maybe the market's not as familiar with is adiabatic depletion due to, in our case, fossil fuel use. That's what that PF means. And every one of these have an equivalent unit, and you produce this data and then put it into a special format set by an ISO standard called an EPD, where an architect or anybody can download this material and be able to compare those things through a set criteria like what you have with LEED or IFLI processes, and there are other ones. Green Globes is another one. And you can optimize the impacts of the product. It can be something as simple as accessing EPDs and comparing EPDs of products, or it could be just going back to the tools and doing the whole building LCA model. But all that data is there. Next slide, please, Kayla. And all that data is there. And we also, I know it's a lot of information, so we put together education tools on the MCA website. We have an AIA approved course. So I'm just making you aware of that. That's the written version. There's an online version as well. That link's there to access, or you can just go to metalconstruction.org and access it directly from that site. But it kind of explains how that system works, and then how to gather that data and be able to understand it on a basic level so you can make those comparisons. I think that's the last slide. So what we're really doing, we're working very hard, and this is not just Metal Construction Association. I mean, the American Iron and Steel Institute has been a huge facilitator in this. If you look at those LCA reports, what they'll tell you is most of our environmental impacts happen when the material, or already have happened when the material hits the gate on the factory. So it's primarily in the steel processing or aluminum processing, and so we work with those trade associations, and they continue to work within their groups to produce and refine that data, and these EPDs get updated every 5 years on the basis of that. So, our biggest challenge in all this has just been, getting people past some of their the biases they might have against metal or other materials that they pollute or they're energy efficient. Well, all of this, the energy inefficient, all of this is wrapped up in these reports. It's in the data, and it is third-party verified and checked, and the story is what the story is. There's no need to go back to these old biases and rules of thumb of X% recycled content and that going forward. And so we're really trying hard on the educational side to keep people, make people, number one, aware of this data that is there and how to use it, and rather than just go back, hey, I've got this much recycled content, check box. So a lot of that effort going forward in the industry, and we're happy to be a very big part of it.
Great, thank you very much, Bob. before I got a question, Hafsa, to start with you, but before we get to that, remind everybody to just submit your questions on the panel there. And one little bit of housekeeping, Rick, somebody wants to know how they can view that video again. Is that available on your website or?
Yes, it is available on the website. I'll go ahead and provide a link to that at the end of the session here.
Okay, great, thank you. Hafsa, one of the you and I talked about the box factory, and I understood that it came out as a result of work on another project as well. Part of our discussion got into kind of what you face in the marketplace when you're trying to talk about sustainability and metal building products. What are kind of the big objections you face in the marketplace in accepting metal building products, tying them to sustainability and achieving sustainable goals?
That's a very good question, and it's a layered issue. So there are products which are carbon sequestering, and then there are products which are carbon producing. And generally, by reputation, metal products fall under the second category because just to produce 1 ton of steel, 2 tons of carbon dioxide is released in the atmosphere, and also the whole process of extraction of iron and processing it to make steel products is a pretty energy intensive process where temperatures can go up to 2,800 degrees Fahrenheit in some parts of the process. With that said, metal products do have a positive with that these can be recycled and new products can have recycled content, but that raises another issue, and that is that scrap metal is not in equilibrium with demand. We're still lagging there. And even if we were in equilibrium, 70% of the steel products are produced in basic oxygen furnaces, and those can only take a certain percentage of recycled content. For the rest, in order to process recycled content or scrap metals, we have to use electric arc furnaces, and those are not so common in the industry. So a major disruption in the industry is needed. But if you start looking at embodied carbon, there's a category for metal reduction, and there have been studies done by Cambridge University where you can actually reduce carbon emissions by reducing the use of materials, or by reducing materials in general. And that's where prefabrication plays a very important role, such as in my project that I just presented. Because in our project specifically, and in prefabrication, there is very minimum construction waste because it's so efficiently produced, and that's a pretty big positive in the embodied carbon discussion about metal products. That's one. And also, Bob touched on it a little bit, but if you look at LCA, there's, most EPDs cover transportation, extraction, and manufacturing. There's a whole category of, during the use of the building. And then we get into topics such as a product that we're specifying, is it low maintenance? Its longevity. Also, will it require an extra layer of cladding with a different material just to make it fire resistive, or to give it insulation properties? And that's where you start seeing the positives in metal. And also, in our case, how will in the project that I showed, how will it behave in the case of a natural disaster, such as a seismic event or wildfires, which is a season in California now. So in the whole complex layer issues of the building's life cycle and the building's life, there are issues where you can kind of, when you're specifying the projects, you can start looking at the pros and cons, not just up to the manufacturing stage, but there are certain positives that start happening during the usage of the building, and if the product is just going to last longer, and will it behave better in terms of a natural disaster. So it's a layered issue.
Yeah. Hey, Rick, I forgot who the client was for the Marvin Gaye project, but a lot of that kind of education, that what Hafsa was just talking about, is something you need to communicate with the client to bring them kind of up to speed on how this works. How do you do that in a way, and how do you get them to the point where they're accepting of the ideas that you're talking about with sustainability?
That's a good question, Paul. In fact, the client is actually a two-part client. The user agency in this case was DC Department of Parks and Recreation. But like general services at the federal level, DGS, the Department of General Services, is our actual client. So DGS and DPR, sort of a two-headed client in that regard. And basically, what's nice is that we're actually working with a fairly forward-thinking client. And so they put out reports, Sustainable DC, Resilient DC, that are really all about taking the city to the next level in terms of sustainability and resilience on many levels. So when Hafsa talks about the ability for metal to be a resilient material or lead to a resilient outcome, like the Marvin Gaye Recreation Center, that helps me pitch this. And in many ways, sometimes the product pitches itself. But we'll bring to them sort of fairly forward-thinking notions. They're already bought into the notions of daylighting and energy efficiency, but oftentimes we'll bring them a new idea, something that's maybe carbon neutral. So in some cases, we've been dealing with CLT and mass timber over there. But in this case, the metal panel was part of a system that provided control of solar gain, which allowed us to downsize our HVAC systems. And that's just green right there, green money and green for the environment. And then with the natural ventilation system, metals are used in that entire system, from the inlets throughout the building and then to the outlets as well. And so, pitching durable materials that are lightweight, easy to manufacture and, transport to the job site helps us pitch not just the material itself, but even the systems that they make up. Does that answer the question?
I think, yes, it was great. Thank you. Hey, Bob, ideas of sustainability have gone through a massive evolution. I mean, if you look at what we were doing in the 1970s and this embracing of trauma walls and all these crazy ideas, it's gone through this kind of change, and it's continuing to move, sustainable construction kind of continuing to move. What are the challenges that are faced by metal and how we see the sustainable construction moving?
Oh, I think we've hit on it to some degree. That is, there's a lot of predisposed impressions that people have that may or may not be true. And the metal industry, like every other industry, is constantly working to be cleaner and more of a steward to the environment. And particularly with these LCAs and the data collection that we've gone through, it is not just used to produce documents that people can download and do this analysis. It's actually used by the industry. Okay, let's look at this. What are our inbound burdens that we carry? As I mentioned, most of it is actually already in place in the material. Hafsa hit on it. She said that, regarding the EAF process versus the BOF process. And so I would say that you got to remember there's a couple of different things working there. First off, there's product mix. Metal roof and wall cladding, what she says is accurate. It tends to be more more BOF steel, just because of the ductility requirements that are in it. But structural steel and to a degree cold form steel as well, you get a lot more of the AF mix. So AISI has done a lot of work, American Iron Steel Institute, on this. If you want to go to www.recyclesteel.org, they talk about product mixes and which products tend to be made from which processes. That's number one. The second thing that you got to remember too, is there's a geographical aspect. Rick and I were talking about this on the phone earlier. There's a geographical aspect to this. Where Hafsa is, you see a lot more foreign steel. A lot of steel comes over from China just because of economic pressures. But where Rick is on the East Coast, it's probably 10% or less foreign steel. So you get those product mixes as well. The AISI data is generally based off of North American steel, the world, but there's also some world steel data there that's available too. I think if you talk to most LCA practitioners, they'll tell you that the data coming out of Asia is just not well known and doesn't meet the rigor, certainly not of Europe and probably not even of what we do in the US. And so that foreign steel component probably is something that we would work on as an industry to make sure that there's the clarity and the transparency there as well. But I'd say really getting people, all this wraps into the biggest challenge, which is getting people to kind of change how they think. It's not just recycled content now or locally sourced materials. It's all based off of these complex, very scientific analyses that are done then you have to educate yourself, really, which obviously Hafsa has, and I know Rick has too. You have to educate yourself on what this data means, because it's got to be like any other data, right? Garbage in, garbage out. It's got to be taken in context and analyzed fairly across all paradigms. And that's the whole purpose. That's why ISO standards drive this. So that education element is really, it's a mountain for us to climb, and that's step one in getting people past those biases they may have that just plain flat aren't true anymore, or maybe not even have been true in the past.
Even at the same time, Bob, sustainability is not just a series of boxes that we check, right? We looked at a lot of different materials to provide sun screening at the Marvin Gaye Recreation Center, and that was the best product for that use right there. And that was a significant energy cost saver, as well as cutting back on glare, so it improved the interiors. So the data are good, but also design is more than just a sum of data points. And so to that point, I like your statement that we need to think outside the box, essentially, when we're thinking about metals and sustainability.
Yeah, and I think durability and life cycle has a lot to do with it. I mean, yeah, we have
Absolutely.
these impacts, but we're talking about a material that lasts 40, 50, 60 years, right? That will never have to be replaced,
Right.
probably on a roof, and on a wall, it might have to be repainted, and you got to look at that cradle to grave aspect of it. Exactly right.
We're getting some questions here, but I'm going to be selfish and ask one more kind of question here, and I think it's maybe a little esoteric. And that is, and you kind of touched on it, Rick, it's this balancing of high concept design and performance. And we see lots of projects that are highly sustainable, that have a completely new look, are kind of redefining what high concept design is. And we see a lot of projects that are right down in the path of high concept design and are trying to be sustainable. How do you balance those two things? And Hafsa, I want you to weigh in on this one as well, because this is a tough topic, it seems to me.
Well, I get this question a lot too, Paul. I think the simple answer is that we're not looking to balance something against something else at all. It's not an either or proposition of trying to not do too much of sustainability versus too much economy. It's both. It's this and. And so as we see the AIA redefining what it means, what design excellence means, we're designing not just for ecology and wellness, but we're also designing for economy, long life, loose fit, you name it. It's an and proposition is the simple answer to that. And I'm sure Hafsa has other comments in that regard too.
Well, well, the older I get, I tend to become more, I don't know, philosophical on the issue. And it just, for a couple of decades, we've been struggling with this, whole philosophy. If you can actually achieve net zero principles in Western economies or in a capitalistic society, not that I'm a socialist, please don't get me wrong, but you start to see, what's at this point with, goals for Paris Agreement to be at 1.5 degrees by, a certain date. We need to reduce our GHGs by 65% by 2030. And that's a very ambitious target, and I don't know if we're going to make it. So I think our goals and strategies just need to be focused on the long-term vision for the planet. And if cost has to be compromised, then I would be probably a little more on the other side of the spectrum, saying that maybe for the longer goals we should compromise cost.
Bob, a quick question on insulated panels has come up for roofing. I know that the answer is yes, they can be used. Insulated metal panels can be used for roofing, but can you expound on that a little bit? Because they're excellent for energy efficient issues.
Right. Yeah. No. The answer is absolutely yes. Every major manufacturer that I know of makes a roof panel. I would tell you that they're generally available in two types. There's the classic roof fastened, but just about all of them have a standing seam variant, T-panel configuration, or a classic Pittsburgh seam. They are variable widths. Most of them are 42 inches wide, but you can get them in narrower widths as well. So there's a big product offering for roofs. That's the short answer. and same thicknesses, anywhere from 2.5 to 2.5, depending on profile, all the way out to 6. And some manufacturers even come out with 8-inch panels now.
We have another question. As an architect or engineer, please share your perspective regarding using aluminum in your design, both for interior and on the exterior, and what are the main benefits aluminum provides, and elements of home or structure do you find aluminum more preferable? And I think that last one is kind of interesting because you do want to put the right material with the right function. So Rick, why don't you kind of jump into that one if you can, or maybe Hafsa, since you started to speak, I guess. Hafsa, why don't you start?
Yeah.
I'm messing that up. That's my fault.
No, no worries, no worries. I'll speak briefly about Marvin Gaye Rec, Hafsa, and then hand off to you. As you all saw from the video there, Marvin Gaye Recreation Center, that ribbed perforated metal screen that provides energy efficiency, controls, glare, so provides a better indoor environment. We looked at a lot of different materials there. Steel wasn't going to cut it because it was too heavy and it was going to rust. Suspended above, the ground there, we wouldn't be able to get to it as easily. Fabrics are just not going to have that lifespan, and so how cost effective and sustainable is it if you have to replace a product 4 or 5 times in the normal lifespan of the aluminum itself? And so that ended up being the product that really suggested itself in that location, Paul. And I think that was the simple answer for that one. Meanwhile, if you look at the rest of the project, we clad the thing in steel because it's down near grade or close to it, just up off of grade. We wanted to make sure that in a neighborhood where kids are playing football right there and soccer, that thing wasn't going to get beat all to heck. So that was those two materials really suggested themselves. Hafsa?
Yeah, like Rick said, the corrosive resistance is obviously one, and lightweight application for, especially in Rick's project as a brise-soleil, you cannot go with a heavier option. So those are two obvious ones. And also, if it's being used in storefronts, thermal efficiency can be noted if there's a thermal break. I do tend to notice that if the aluminum frame of a storefront is, single pane or doesn't have a thermal break, then aluminum products do have a tendency to condensate on the inside, especially, in the initial cycles of the project. So, but yes, those three, thermal efficiency, corrosive resistance, and being a lightweight in certain applications like a brise-soleil will be the obvious reasons.
Hafsa, you really had to think outside of the box when you were approaching the box factory. Just kind of a new concept approach to design. Are there some kind of like uncommon or counterintuitive ways that you approached metal building materials to contribute to sustainability? Or are there things that just kind of like, wait a second, that's a new way to think about it?
Yes, well, most of the building shell is exposed, right? So we get into low maintenance, which is a good thing. We get into fire resistivity because wildfires is a season in California now. Also seismic strength and low maintenance, of course, I touched that on that already. And I think the biggest part why we went this route was prefabrication, because construction waste was just minimal, and the speed of construction, because major elements were constructed in under 12 days, and that was a big thing. So I would say prefabrication and construction waste completely minimized. Obviously, longevity plays into it, and low maintenance.
Rick, are there some kind of unusual or different approaches that you've experienced in your career?
As far as
give away asking for using the metal in sustainable applications, asking you to give away some of your trade secrets, maybe.
No, but we do come up with various challenges. Hafsa spoke about thermal bridging. Sometimes it requires us to think outside the box. And I love your project, Hafsa. We're often having to think outside the box as well. So for example, where a ribbed metal screen, is held by a steel post that's coming off a steel structure, we've got to create a break between those two because of the galvanic action. And then meanwhile, back at the, so there's a pad there. Meanwhile, back at the enclosure, we need a thermal break to make sure there's no thermal bridging across the steel to the interior of the project, interior of the building. And then at that balcony that you saw, we actually have structural steel that's cantilevering out past the building enclosure to create this balcony. In that case, we actually used an insulating coating, a paint, if you will, for a few feet on the from the perimeter to the interior in order to counteract the thermal bridging in that case. So, you know, it does require us to think outside the box, but the more we, you know, use various metals in so many different ways, the more we get attuned to the details to how to make it work better and be more functionally sustainable.
You know, Rick, one of the things you may want to look at is you know, address those things. Somebody asked about insulated metal panels. I mean, that's a product that's
right.
widely used, been widely used since the 70s for cold storage. And, you know, that industry has thermal bridging figured out, have had thermal bridging figured out for a long time. Thermal bridging isn't a nuisance in a cold storage facility. It's a destructor. It can cause tremendous damage. And the manufacturing companies that we represent on the IMP side of the business have developed details, and they're readily available for download on the website that talked about how to configure insulated metal panels, where to make cuts and thermal breaks so that you're preserving the structural capacity of the panel, but providing an accurate thermal break. So you're not alone in that. Industry can help you. So that's something else I think people should remember.
Thanks, Bob. More tools in the toolbox.
Bob, there's Rick mentioned coatings, and that made me think of zinc coatings, and there was a bit of a to-do about zinc wash off of panels, I think in the Pacific Northwest.
Yeah.
And how that is not a sustainable, could potentially not be part of a sustainable environment.
You know, when that started, that just goes back, gosh, to the early, even maybe before 2000, you know, when some of this data started coming up. And so we got concerned about it as an industry. Both MBMA and the Metal Construction Association got involved, did some various testing and tested a lot of different materials. MCA, for instance, worked with the state of Washington Department of Ecology and did a series of tests. And we were never able to recreate any of the things that some of these other studies were saying they were found. In fact, we couldn't really even find in these studies where these numbers that were being thrown back at us were justified. So just what we found out through doing this research with the Washington State Department of Ecology is that what comes off of a roof in terms of water contaminants is really more to do with the environment around the building than it does the material of the roofing itself. And we found that out because we used a glass element as the control for the experiment. And what we found out was there's actually more contaminants in the water coming off the glass control element than there was many of the other types of roofing products. And so did a little research and kicking around, found out, sure enough, you know, there was some industrial activity happening, you know, 3 or 4 or 5 miles down the road. So, it just, we have never been able to recreate that as an industry. And that's another one of those things is just, you know, we have to continue to research and work to prevent that misinformation from getting out, because it can be quite destructive.
Hafsa, we have a question for you about you mentioned in your presentation about the California requirement for electrical sourcing, and if your project, the box factory, is entirely off the grid, so why would there need to be a requirement for electrical? I think is the question here, or is it just the best alternative?
Yeah. Oh, great. Yes. So the whole California electrification mandate is because they're pushing renewable sources, and if you're using solar, it has to be electrical. It's the easiest conversion, and it's a there's no emissions because it's using a renewable source of energy. Our solar panels are recycled, and they're on-site solar arrays. So we are using an induction stove. The conditioning is zoned. It's all heat pumps. Electrical fans are in place, and also the well is pumped with a solar operated pump. So yeah, I'm actually working with the AIA Committee on the Environment to push the electrification mandates in California. And California has a very aggressive goal to be completely providing all their energy by renewable sources by 2045, 100%.
Rick, I think you answered this a question, and maybe you can expound on a little bit more. What's the selection of the Lucabon product for the Marvin Gaye? You talked about it a little bit with the aluminum, and maybe there. I'm asking if there's a little bit more to discuss there.
We actually didn't use a Lucabon there. It was an ATAS.
Oh, I'm sorry, that was Hafsa.
That's okay. Yeah.
Go ahead, Rick. So go ahead and talk what you did. Rick, talk about what the product you used. And we'll come back to you, Hafsa. I'm sorry, I'm messing that up.
No,
so Rick,
no worries, no worries. No, I think Bob was suggesting it as I was talking with him about some of the cladding material we used on Marvin Gaye Rec. And so on the Recreation Center, we used steel for the main cladding because we needed a level of durability, flexibility. The contractor had subs that were used to working with that. And then we went to the same company, but with a different product. It was basically the ribbed aluminum, which came in a rib that would allow us to span distances, suspended up in the air like that, and then perforated to control the amount of solar gain we were getting in that. So those are the two main cladding materials. And of course, the structural steel, was literally going down into the ground and connecting with these deep foundations that were counteracting scour because it was built in the 100-year floodplain. It was the only place that they had to build this location. And then the other steel I mentioned was, primary structural steel, but also secondary structural steel, off-site components, like stairs that were brought in and dropped in place, the decorative metals, and some of the same things that I saw in Hafsa's project, where you used metals in so many different ways. We used a similar perforated aluminum as kind of a decorative privacy panel on the front reception desk. So cool stuff.
Hafsa, my mushy brain messed that up. The Lucabon was, I think it was specified by you on the San Francisco Airport project. Is that, I think that's
beautiful project.
Yeah. So
yes, it was for San Francisco Airport projects. That's just a requirement by the airport for cladding. It's an MCM, and that project has been around since 2006 and is in a bit of a area which does require low maintenance and durability, and it's been performing quite well. And both those projects that I showed use that material just because it's a requirement by the airport. The prefabricated single-family home is using galvanized sheet panels.
Is there a particular reason why the MCM panels are a requirement? Is it for design considerations to keep a consistency in design, or?
Yeah, I would say it would be design consistency, and also durability plays a factor. I should ask them.
We'll do that right after this. I want to ask all of you, we have another question about coatings, and I'm going to actually make it a little bit broader than this person. This person is asking about what types of coatings to use in coastal conditions. There is a huge variety of coatings, everything from cool metal roofing panels, coatings to all kinds of different coating elements, PVDF, FEVE. How deep do you go into coatings when you're talking about specifying metal products? Rick, why don't you start with that one?
Sure. You probably saw from the images there that in addition to the coating itself, which needed to be durable, and I think in this case it was basically a Kynar finish on the steel panels, we actually provided, there's artwork painted in 2 locations on those steel panels. They're both images of Marvin Gaye when he was performing, and they're done in kind of a real cool stylized approach. But something that would actually be durable, but that could also take that product without having to be compromised was really critical. And so that's why the Kynar finish really kind of made sense there. And I'll be honest with you, I don't recall what paint he used. The artist is actually a friend, local here in Washington, DC. But I don't recall what type of paint he used on that, but I think it was similar. Maybe Bob or Hafsa, you guys have some knowledge on what can be combined or painted over top of a Kynar finish, because it escapes me what that was.
Yeah, there are a lot of
Rick, when did you finish that project? Go ahead, Bob. Sorry.
That's okay.
No, go ahead.
There are a lot of different options there. So they're from a reflectivity standpoint, I would tell somebody, just go to the Cool Roofing Council CRC website. They have a rated product listing directory there that addresses both factory applied and field applied coatings. So that's a great starter list for what you might want to use. But going back to the question at hand, which was coastal applications, I would tell you most of our manufacturer members recommend a painted aluminum panel for that type of application. But you know, it kind of depends, because there's some really nice, just awesome coating systems out there that are 3-part coat systems plus a clear coat that have great performance in coastal environments as well. They might be a little more expensive, but they're very high end and very durable. And so it just kind of depends on where you want to be in terms of the technology.
Rick, when did you finish that project? I had a question for Rick. When did you finish that project? Because it seems like that painting is doing very well. Whatever finish you used.
Yeah, we had just finished it a couple of years ago. Is when it delivered, and that was one of the last things he did, was to field apply the integrated artwork. It's great because Washington D.C. on all their public projects, they allocate 1% for art, and they like to promote local artists. And so we work really closely with artists to kind of incorporate it into the architecture, so it's not just building here, art added to it. But yeah, it seems to be weathering just fine, Hafsa. Yeah.
We do have a question here that may be opening up a can of worms, and it refers to MCM panels, FR cores versus PE cores. I know it's a very touchy topic right now in the industry because of recent events. What's been your experience, Hafsa, in FR cores versus PE cores?
I think I would defer this question to Bob because he probably has more technical knowledge. Yeah.
Okay. So I would tell anybody that, you know, that a lot of these events that have happened, we just don't see them happening in America. And I'm not saying they couldn't, but we have not seen to anywhere that near the extent. I'm personally not aware of one fire similar to what you saw in Dubai and other places in Europe. And I would tell you the main reason why that is that we test, very rigorously test those products using a test called NFPA 285. In fact, with Metal Construction Association's annual meeting, we just had a very long discussion about that test. That is a very rigorous test, testing the flammability of the interior of a wall. And it gets drawn in by code for MCMs and IMPs as well. Anytime you've got a combustible material and otherwise non-combustible assembly, it's got to be NFPA 285 tested. And that test, it really separates the performing versus the non-performing products. And we just haven't seen that in North America because that's a code requirement here.
Yeah, it's my understanding North American codes are just more stringent about the use of FR cores than other places.
Well, you know, yes is the general answer to that question, but every code is different, right? They all have different tests. The test variations are different. You know, like Canada doesn't have they don't use NFPA 285, but then they have some other tests they apply. It just, I would say, yeah, in general, North America, it is more rigorous, but it's just very different. And I think what we've done in America, particularly in NFPA 285, is we've done a good job making sure from a code, not MCA, but as a code development standpoint, we've done a good job making sure that the test that we specify in the code is fit for purpose. And I borrow that phrase from one of our members because he's absolutely dead on. That's the way to say it. That test is fit for purpose, and we just the results of that test and the qualifications that it generates, we just haven't seen those issues in North America.
I want to circle back to life cycle assessments, which we talked about at the beginning, and kind of come back to that. And Bob, I think you've mentioned to me that there are kind of some new trends at play in life cycle assessments and what's changing and what's happening in that area that may pertain to the architects and the other folks here.
Well, it's been actually Hafsa said kind of hit on it already as well. We started out with you know, the ISO standards and the impact indicators that those standards dictate that we use, and we continue to use them. And the whole purpose is that we don't try to provide one single number that says, here, this is green or this isn't. I mean, the data speaks for itself, right? But we have a finite number of impact indicators and that are published. The changes that we're seeing, particularly out in California, is really focusing on carbon reduction, almost to the exclusion of the other impact elements, indicators, which personally, I have some mixed feelings about it, because there are some very important things that those other impact indicators are supposed to represent. And having done all this work and this data, I'm perfectly comfortable with where we set as a product. I think it's a great indicator. What I don't want people, or I don't want the market to do, is focus on certain elements of those indicators and then kind of not look at the rest of the picture, the impact picture that those products paint. And that's the whole purpose of the ISO standards, to make sure each one is individually defined clearly, and that anybody can access that and be able to compare those directly one-to-one. So as long as it's done in the context of the ISO standard, that's fine. I see some trends towards moving away from that, and that's a little concerning.
We've got a couple more minutes here, and Rick, I have a very specific question that may be testing your memory. Somebody would like to know what the name and model number of the perf panel you used on the exterior of the I didn't really, you didn't know there was going to be a quiz involved in this discussion. But.
No, I don't. But I tell you what, you saw me typing before. That's because I was asking my team in real time to get the link uploaded, and I think we did get that loaded up there while we're going. So I'll go ahead in real time request that information, but I think we might have to put that out after the prez today. Okay. To be honest with you, I just don't have that on the tip of my tongue.
Let me do a quick look. Got just a couple of minutes, and I think in the chat you can see the link there. Any final questions from the panelists for each other on metal's role in sustainability? To wrap things up, Bob.
Hafsa and I talked during our pre-meeting, and I wanted to. Rick and I actually talked about it as well. I just want to encourage people, when they need recycled content data in particular, that's a lot of questions that people ask, to look at AISI. Now, I believe Hafsa's question was particularly for aluminum, but there are industry associations that do track that, and it's a difficult, going back to the manufacturer may not necessarily be the right answer, because you might get something that's true for a certain period of time. But when we do these to the industry associations, we're doing very rigorous statistical analysis so that we know what's likely to happen. And so I would just encourage them, look to the trade associations. We can point you in the right direction.
Yeah, I'll say, Bob, from our conversations about LCC and LCA, there were points where you were getting so granular that I admit to glazing over a bit. But my main takeaway really is that it is a complex process that is evolving, which is terrific. And my other big takeaway is that it really does depend where the project is located to understand which metals are going to have a good or not so good LCA or LCC for you. In our case specifically, you mentioned it earlier. I'm doing a project in DC, for example, Washington, DC, like Marvin Gaye Recreation Center, as opposed to Hafsa, who's maybe doing something in San Francisco. And I've got steel coming out of Pittsburgh and Western Pennsylvania, and aluminum coming out of Tennessee. So I don't necessarily have to go to overseas sources. My LCA, LCC is going to be very different than a West Coast project, right?
Right, and like you said, it can get really granular, and I apologize. I do that sometimes.
Oh, no apology necessary. I'm glad you have all those data points.
Paul's trying really hard not to roll his eyes. He's been in part of those conversations, but yeah, it is complex, and I'm not an expert. I've just worked with the tool manufacturers, and I've worked with UL, and I've worked with, so I know what they're looking for. That's what it
Yeah.
comes down to.
I apologize. Most of that's over my head anyway. Hafsa, you were going to come, you had something to say there.
About geography? No.
I thought you'd start.
We use metallic. We use metallic, and they're located in Texas for the single family home.
So that's the end of our panel discussion. We'll wrap things up here. I know we have MetalCon Live has some more panels and webinars coming up. Thank you all for joining us today. Hafsa, Rick, Bob, thank you guys so much for bringing your expertise. And a lot of it, I'm afraid, does go over my head, but I always learn something, and I appreciate that.
Thank you.
Kaylin,
Thank you.
are you going to sign us off here? Whoop, have you on mute. All right. Thank you all very much for being here. Thanks to S5 for sponsoring this event and making this possible and supporting education in the industry. And thanks very much to all our panelists. Everybody have a great day and enjoy the fine spring weather.
Great. Bye, folks.
Thank you, everybody. Be
Thank
safe.
you.
Thank you. Bye-bye.